Hello everyone, I am going to walk you through the process of identifying outliers in your data sets. And what I've done is I've given you a data set that has essentially three columns of information. The first column is kind of useless, it's just store number. It's just a kind of a key or a designator. And then the other three columns I've given you are employee hours, store revenue, and SKU sold. Employee hours are the number of hours that an employee worked in a month, or the average number of hours that the employees worked in a month. The store revenues are the store revenues for that particular month, and the SKUs, or stock keeping units, are the number of units that were sold. That's basically the inventory that was sold in that particular month. These data are for 300 stores, so we start at row 302 and we go all the way down to row 301, and we have these three values for all three of those, or these three values for every one of those stores. What I have done is I've sprinkled in outliers, and some of them are outliers that are way out outliers, and some of them are outliers that are pretty close to the mean. And what I want you to do is to create some visualizations using Microsoft Excel charts, and I want you to show me first each of the three columns in a scatter plot when it has outliers in it, and then I'm going to show you how to remove the outliers, and you'll go through the process again and show me each of the three columns in a scatter plot with the outliers removed. So I'm going to walk you through the first one. The first thing we're going to do is we're going to select the first column, which is employee hours. And there are 6 outliers in this particular column, and I'll show you how to figure out which ones they are and what to do about them. But the first thing we're going to do is we're going to look visually at the data set. So I'm going to go ahead and insert. I'm going to go to recommended charts, and one of the recommended charts for this particular data set is going to be a scatter plot. That's just a plot where all of the data points are represented by a single point on the plot. And that's actually the first entry for your submission for this week. It's just this employee hours plot. There are a couple problems with this employee hours plot. One, it's not terribly useful. And the reason why it's not terribly useful is because of the second reason, because it has outliers in it. When you have outliers in it that are extreme values, Microsoft Excel will do the best it can to accommodate all of the extreme values. So what it's doing now is it's accommodating these three extreme values by putting them on the chart and scrunching everything else down at the bottom of the chart. That's not terribly useful for us because we don't have enough room to be able to see a whole lot of variability. You can also see at the very, very bottom, they've got some what could be outliers down here as well. We're going to have to assess those and determine whether or not those are outliers. So this plot and this data set, the data set itself we're not able to see it very well, and that is just an artifact of the fact that it has such extreme outliers in it. So we'll set that aside for now, and I'll show you how to determine which of the employee hours entries of the 300, which of them are actually outliers. Now, one of the videos that I posted, the general videos that I posted, walked you through this process. And I'm going to walk you through it again because I think it's very useful. There are standard accepted processes for determining which data points in a data set are outliers. And there's ways to determine the cutoffs to determine which of those data points are. And the video I showed you shows you that. I'll show it to you again. The first thing we're going to do, I'm going to have you first of all ignore outlier and label. We'll come back to those. So those are the two that are directly next to the SKU sold. Don't worry about those for now. The first thing we're going to do is we are going to generate quartile 1. Now, a little explanation about what does that mean, quartile 1. In any data set, we can divide the data set into 4 quartiles. And those 4 quartiles are the 25%, 50%, 75%, and 100%. And what we're looking at in each of those, in quartile 1, we're looking at the very lowest values all the way up to the 25% or the 25th percentile, the lowest quarter, all the data points that make up that lowest quarter. In the second quartile, we're going from basically the 26th percentile all the way up to the 50th percentile. And that's the second set of the 25% of the data points. And we do the same thing with quartile 3 and quartile 4. Now, the reason why we're using quartile 1 and quartile 3 here is because the outliers it's how we can account for where the outliers are located. Now, when we come up with a value that is quartile 1, what we're saying is give me the highest value that is in the lowest 25%. And the highest value in this particular case that is in the lowest 25% is 130.4. That becomes my quartile 1 value. When I can do the same thing for quartile 3. Give me the highest value in the third quartile, and that's going to be 195.8. By identifying quartile 1, highest number in the first quartile, and quartile 3, highest number in the third quartile, we're essentially capturing all of quartile 2 and all of quartile 3. So that is what we call the interquartile. And quartile 1, anything that's lower than 130.4, we're going to exclude. Quartile 3, anything that's higher than 195.8, we're also going to exclude. And that's where the outliers are going to be. They're going to be in the very low or the very high. So by looking at the quartile range between the very top of 1 and the very top of 3, we're really picking up quartiles 2 and 3. How do we do that? Well, there's a function in Excel. If you go look at this function, you'll see that I can set up a quartile. And what I'm setting up a quartile on is I'm setting up a quartile on column B. And column B starts at B2 and goes all the way to B301. So I'm going to go ahead and say from B2 to B301, give me the quartile 1 value. And that's going to be the very top of quartile 1, and that's 130.4. When I want to do the same thing for quartile 3, all I do is designate the same range, and I come over, and this time I say I want quartile 3, and it's going to give me the top value for quartile 3. Okay? That's how we get those values. Now those values are key in helping us determine what is an outlier and what is not an outlier. Now the next thing we need to know is we need to know what is the interquartile range. Well, remember I told you that when we calculate quartile 1 and go up to quartile 3, that's our interquartile. To determine the range, we subtract the smallest value from the largest value. And the smallest value in our case is 130.4. The largest value is 195.8. So we subtract 130.4 from 195.8 and we get an interquartile range, IQR, of 65.4. That is the next key piece of information in our process. All right, two more things we have to do. We have to determine an upper limit for our data set and a lower limit for our data set. The upper limit for our data set is the maximum value we would select or that we would choose and say that it's not an outlier. And in this particular case, that value is 294.0. Well, how do we determine what that is? Very simple. We take the top of quartile 3 and we add in 1.5 times the interquartile range. And if you look at this formula, you'll see H2, which is equals H2. H2 is our top value, our maximum value, plus 1.5 times I2, which is our interquartile range. And that's a fixed formula for you, easy to put together, and that takes care of our upper limit. For our lower limit, we're going to do the same thing, just in the opposite direction. So what we're going to do is we're going to take quartile 1, and we are going to subtract out 1.5 times the interquartile range. And that's what you see here on the lower limit. We say G2 equals G2 minus 1.5 times I2. So here's G2 minus 1.5 times I2, and that leaves us with a lower limit of 32.2. So just to recap, we calculated the quartile 1 value for employee hours. Then we calculated the quartile 3 value also for employee hours. Then we subtracted quartile 1 from quartile 3 to get the interquartile range. Then we determined our upper limit by taking the value that is in H2 and we added 1.5 times the interquartile range. For the lower limit, we took the value that it was in G2 and we subtracted 1.5 times the interquartile range to get that value. Okay, those are our parameters, and be specific, they are only for column B. The next thing we're going to do is we're going to use a fancy function. It's not that fancy, actually, but it's a function in Microsoft Excel called OR, and we're going to determine whether or not something is an outlier. So let's look at the first one. The equal sign OR is a designation that we're going to use a function. We have an open paren, we have a double open paren because we're going to look at two different things within inside the parentheses. Okay. The first thing we're going to look at is the value in B2 greater than the value that is in J2? J2 is over here. It's our upper limit. J2 is 294.0. B2 is 53.38. It is not greater, so that is false. Okay. Then the next thing we're going to look at is the value of B2 less than the lower limit, or the value that is in K2, and that is 32.2. It is not lower than 32.2, so it is also false. If you're familiar with Boolean logic, anytime you take an OR statement, it only takes one of the two items to be true for the entire statement to be true. But in this particular case, they're both false, so your outlier designation is set to false. Okay. Let's look at the next one. The next one, 173.46. 173.46 is lower than the upper limit, and it's higher than the lower limit. It does not exceed either of those limits. So it also got a designation of false. Our first outlier down here is 900. 900 becomes true because 900 exceeds our upper limit. Because it exceeds our upper limit, it is now an outlier, and we don't have to look at any other part of it. In truth, the way that we've set these up is they can't both be true at the same time. That's technically impossible, but we don't have to look any further just to know that this is an outlier, and that's why it got a designation of true. So we'll come up here, and we'll just do the first one. The first one is OR equals OR. We're looking at B2. There it is, B2. So we're going to compare it to J2 and K2. And we're going to do this, open paren, double paren. We look at B2 to J2 first, close paren, put a comma between them, open paren, B2 is compared to K2, then we close out with a double paren so we can close out the one part of the equation and then close out the whole equation. There's one other thing I want to call your attention to. Maybe some of you are aware of this, but I want to make sure you're fully aware of this. B2 is something that is going to change because when we go to the next one, we're going to be looking at B3, and then we'll be looking at B4. So we want that to change. As you well know, Microsoft Excel will actually accommodate any changes you make depending on where you've actually positioned your cursor. But the values we don't want to change are J2 and K2. And so when we type in J2 and K2, we can either manually put in $signs, $J, $2, and that will say, don't change this no matter where you move this equation. Don't change it. Always look at J2 and K2. So we can manually put in the $signs, or we can just write in J2 and then hit the F4 function or the F4 key, and it will automatically put the $signs in for you. Okay, so we can do B2 is less than or equal to K2, put the designation of the $signs in for what we call absolute cell reference, and then now you'll see that every time I move this, actually move over here, every time I move this, it changes just the things that don't have the absolute cell reference or the $signs. So that is how we can take care of this. Now, that's a lot to type 300 times. Well, you don't have to. You can copy and paste. And the easiest way to copy and paste this is once you've set the equation up for the first position, you can move your mouse cursor over to the far right corner of that particular cell. And normally it looks like kind of a fat plus sign. If you move it over to the far right center, it changes to a really skinny small plus sign. And if you hit double click on that, it will populate all 300 fields immediately, and you'll get all the values that you need. And now what you've done is you've identified all of your outliers. Okay. I went through and did an extra step that is completely unnecessary and completely optional. It just was easier for me to be able to see what was going on, and I did an if statement. So you're welcome to try this if you want, but if, in this particular case, E2, here's my E2 right there, if it's equal to true, then do the very next thing, or set the cell equal to the very next thing. Otherwise, do the thing after that. Well, in this particular case, my E2 cell is not equal to true, so that's false. So it's not going to do the next thing, it's going to do the thing after it. So these are all blank, and that's the designation for blank. So we're blank all the way through here until we get down to our first outlier. If E18 right here is set equal to true, it is, so it's going to look at the very first thing and it's going to set this field to outlier. Again, completely unnecessary. I've already used the outlier column to designate what my outliers are, but I just threw that in there just so that you could see how you can use an if statement to determine whether or not, make it easier for you to see what you want. All right, now how do we deal with the outliers? Well, the first thing we can do about the outliers is we can go ahead and take a look at what they are. We see, we saw we had 900. We have another outlier here that is 14. One thing that might be easier for you to do is to just go ahead and change the font. Change the font to red. For all the outliers, change the font to red. That way when we cut and paste them, then we only have 5. I thought we had 6. Looks like only 5. Okay. That way when we get ready to cut and paste them, it's easier for us to see what we need to remove. So one thing we can do, and one strategy that's commonly adopted when you have outliers, is to take the value, the mean value of all the non-outlier values, and use those to in place of the outliers. So what we'll do is we'll go ahead and take this cell and we'll copy it, and then we'll come over here. I've done this a couple times already, so I'm just going to overwrite one of the ones that I've already done. And I'm going to say paste, use the first paste function so that it keeps the formatting of the red numbers. And now I can come down here and I can say, I want to get rid of these outliers. So I'm going to go ahead and take this, right click on it, go to delete, and say shift cells up. Boom, that outlier is gone. Do the same thing for the next one. Go to delete, shift cells up, that one's gone. Right, two more. Oops, right click on it, right click, delete, shift cells up, and then to my last one. Oops, nope, I didn't want that. Go back, go back, go back. Did the wrong thing. Delete, shift cells up. Okay, outliers are gone. So what am I going to do now? Well, I already did it over here, but I'm going to calculate the average. So equals AVERAGE, and that's going to be from, I'll just designate it by clicking on it, from N2 all the way down to my last value. Then I'll close that out with a parenthesis, and it gives me 162.56. All right, there's my average, and that's the value that I'm going to use in place of the outliers. So I'm going to go back to my B column. I'm going to find those outliers. I'm going to replace them. 162.56. I don't care if they're red anymore. They could be red, they could be black, whatever. Doesn't really matter. Okay. Two more. And the last one. Okay. Now I'm going to try one more thing. I'm going to look at my data set with all the outliers removed, and I'm going to use the same scatter plot that I used before. This would be the second thing that you would turn in. You'd have your original employee hour scatter plot, and now you have your new employee hour scatter plot. But what I want to draw your attention to is something that I think is pretty important, and that is the fact that we don't have outliers anymore. So now that's the chart that Excel gives us allows us to actually get in there and see a little bit more in a little bit more detail the data that we have, because we're not fighting against the outliers. So we can also expand the chart to show it a little more cleanly. But it just shows us kind of what the outliers do. Not only do the calculation or the visualization piece, but what it can do to all your analysis. If you've got outliers in there that just shouldn't be there. So we've done this now for employee hours. Go ahead and get rid of this. And what I want you to do is I want you to do it also for store revenue and SKU sold. So again, you're going to turn in 6 things. You're going to be the 2 charts for this, the 2 charts for this, and the 2 charts for this. How do we calculate the quartile 1, quartile 3, interquartile range, upper limit, and lower limit for the column C and columns D? Very simple. Just go through and take what I have put in there. What I put in there is for B2 to B301. Just change that to C2 to C301. Same thing here. Change that to C2 to C301. Interquartile range is just the difference between these two. You don't have to worry about anything there. And your upper limit and your lower limit are already set for you. You've got the right values in G2 and H2, and you're multiplying the right value in your interquartile range, which will adjust itself when you change G2 and H2. And your lower limit will do the same thing. You're going to have to come back over here for this outlier column, and you're going to have to identify that you're looking now at C2 comparing to J2 and C2 comparing to K2. Again, make sure there's no absolute cell references on the C2 so that when you double click and drop it all the way down, it'll give you the right values for where the outliers are in column C. You'll do the exact same thing for column D. Capture before in a scatter plot, the after in a scatter plot, and turn them both in as this week's assignment. Let me know if you have any questions.